Throughout the past few months, we have developed a quite range of different demand forecasting pipelines together with inventory optimization to suit quite a few different business needs. I'm going to start with a very straightforward demand forecasting plus inventory optimization pipeline. And later, I'm going to have 2 slides. I know today is a demo day, not supposed to have any presentation slides. I really will just have 2 images to show the idea of how the inventory optimization can be actually applied to the business use case. Let's start with the demand forecasting first. We are going to load some demo data set here. Imagine that this data set is some consumer product collected by monthly basis, and there are 5 different SKUs from item A to item E, and we collected the date and time, of course, and the orders of the item, which means, for example, on 2020 April, item C have 232 orders. That is the data that we have collected. So we can do a quick visualization of the historical data. So, yeah, these are the recorded historical ordering data on these 5 items. And once we have all the data being collected and passed into the engine, we can start to do the demand forecasting. For demo purpose, the forecasting is made by item per item or SKU by SKU. We can select. I mean, the input data can be quite flexible. So if it's collected in hourly or daily, we can certainly select the different frequency. But at this moment, we are going to use monthly start since this is how the data being collected. And now we can proceed to forecast. What happened here is we will first split the data into 80%, 20%. We use the first 80% of the historical data to build a model first and use the model to forecast this range, this area where the blue line and orange line are overlapped. We first forecast this area and using this area to compare with the ground truth. Before we build the model, we actually mask out this small part of ground truth. So it's like a test. We hide the answer first, build a model, and compare the model's answer to the ground truth. We can have a sense of what is the model's performance and what is the accuracy. So of course, it is not crystal ball, so it will not be 100% accurate of all of the days. However, we do have a confidence interval, this slightly faded blue color. And compared with the ground truth, which is a blue line, we can see most of the days is actually fell within the confidence interval, suggests that we have already used the historical data to train a fairly good performing model. And start from this point onwards, we are going to make the forecasting of the future. So from this point onwards, we don't have any ground truth anymore because at the time when we collected the data, we don't have the future information. So this part of the orange line are purely forecasting into the future and together with a confidence interval. With just a collection of historical data, we are already able to build a model and make the fairly good forecasting. And I mean, I'm not going to run through everything, but as a demo, this is just a broad idea of how the demand forecasting works. Now, with all of these forecasted value, one immediate thing we can do is actually, as a consumer, as a product factory, or as let's say a supermarket, they will immediately think about we kind of have a sense of how many items could be sold out in the next few months. We should think about what is the inventory supposed to be. So now is the inventory optimization process. We will use the previously forecasted demand for these 5 items, together with some constraint because you have a limited warehouse storage capacity. You will also have a limited budget when you purchase the raw material or when you make the bulk orders. You will have the budget limit. With these constraints and with this product demand information, we are able to plan for the inventory and trying to make the inventory gain as high total revenue as possible with all of these constraints be considered. So here is the recommended inventory recommendations. We can see that from the pie chart, we still have around 1/4 of the storage space left, and we have already run out of all the budget. So this might suggest that hey, we forecasted a very high demand and the budget may not be enough. If you want to get a higher revenue or maintain a good service level, you might need to increase your budget so that you can prepare more inventories and you can sell more items, of course. We can try to increase the budget by a little bit. I mean, not a little bit, we can increase to 35,000 and we can plan the inventory again and see what will happen. Now, of course, by maintaining a higher inventory level, we are able to make a higher total revenue, and we still have quite a bit of budget left. We didn't run out of the budget, and we still have quite a bit of storage space left. Maybe suggest that in the future, we can introduce more SKUs. We can sell more different products. Depends on how the supermarket or how the inventory planner decide to make their business plan. Okay, this is just a snapshot of one single inventory planning process. When we actually apply it to the business use case, this whole demand forecasting process, together with inventory planning, supposed to happen in a quite frequent manner. Depends on how you collect the data. If you actually have the daily data being collected, I do have a rolling forecasting GIF here, showing that as long as you have collected new data, we are actually supposed to make the forecasting again based on the newly collected information, so that with this rolling forecast, you will have a more confidence into the future of what is the demand could be. And also, we do have outlier cases. For example, this point of time, both of the few previous forecasting suggest that on this day itself, 31st July, 2021, a few forecasting suggests that this date supposed to have a high sales, but actually the sales is fairly low. This could suggest two things. One is we are missing some information in the model, so we're supposed to do some further research and collect more information about what is happening in the market. Why do they have a low sales? This is one side of the story. Another side of the story, it also could suggest that there are some outlier events that happen on this day. Maybe, last year, because of the general election, we have an additional public holiday. That could be something that explain why on the certain day the actual sales is different from the forecasted demand. So from a business point of view, the business owner can also make some adjustment based on this kind of gain information. And with the rolling forecasting of the demand, we also need to do a continuously inventory planning as long as we gain the new information, as long as our inventory level being updated. So here suggests the orange line is actually estimated service level. And for demo purpose, I make a very simple assumption, which is whenever the service level is estimated below 0, means on that day itself, there is a high chance that you don't have anything to sell. You will basically sold out everything. So with this piece of information, together with some historical recording of the lead time, and guys consider the MOQ, some other constraints, we can actually go backwards and estimate what is the date you're supposed to plan to make an order or make a replenishment. So for example, if the model suggests that on 7th of January, there is a very high chance that you will sold out everything. Consider 3 or 4 days lead time. On 3rd of the January, you are supposed to plan for the replenishment already, or you're supposed to make the reorder already. Even at this point of time, you still have quite a bit of inventory left in your warehouse. By the time the item continuously being selling, before it completely sold out, likely the inventory, the shipment already arrived at the warehouse, and hopefully by that day you will still have a good inventory level and a good and can maintain a good service level. Roughly, this is the idea of how the inventory optimization recommendations can be applied to the replenishment planning.